Hello, good morning, good afternoon, students. So after 1 day gap, again we are starting the next lecture. That's we are in the lecture 9, unit 1, measurement of pressure. So in the last few classes, we have discussed about the introduction of fluid mechanics. Okay, the introduction of fluid mechanics. What are the various properties of fluid mechanics? What are the various properties of fluid mechanics? And what are the various pressure points? How a liquid drop takes pressure whenever it is in a container. So like this, we have seen some of the topics in the fluid mechanics unit 1. The various properties such as specific gravity, viscosity, surface tension, vapor pressure, influences on fluid motion, pressure at a point, Pascal's law, hydrostatic law. So like this, we have seen some of the concepts in the last classes. So we have derived some of the Pascal's law, hydrostatic law, and also we have solved some problems also. So we have seen other atmospheric gauges, vacuum gauges, pressure gauges also, right? We have seen some of the atmospheric gauges, pressure gauges, and vacuum gauges also. Now in this class, we will discuss a new topic called measurement of pressure. How the pressure is measured by using some devices. How the pressure is measured by using some devices. We will see these things in this class, right? Next one. So if you see the classification of measuring devices, so these are basically classified into two categories. The first category is a manometer devices. The second category is mechanical gauges. Okay. The second device is mechanical gauges. Just unmute yourself, Sheikh. Okay. The second device is mechanical gauges. The second one is a mechanical gauges. So these are the two types of devices which are used for. These are the two types of devices which are used for measuring the pressure wherever it is in the liquid, in the containers, wherever it is in the liquid of containers. So if you see the manometer devices, again here these are classified into various categories. The first one is simple manometer devices. Other one is the differential manometer devices. Okay, no? The first one is simple manometer devices. The second one is and differential manometer devices. So in this again simple manometer devices, we are having other devices such as piezometer device, U-tube manometer device, single column or micro manometer devices. Okay. The second category you are having differential manometer. It is a simple manometer, differential manometer. So in the differential manometer, you are having again inverted U-tube of U-tube manometers and inverted U-tube manometer. So in the differential, you're having U-tube manometer, inverted tube U-tube manometer. So these are the various pressure measuring devices under the category of manometers. What is the second one? So this is the first one. This one is the second one. What is the second one here? Mechanical gauges. So in this mechanical gauges, we are having Bourdon tube gauge. The person of the inventor who invented the device is Bourdon tube gauge, bellow type of gauges, diaphragm type of gauges, and dead weight gauges. The first one is Bourdon tube gauges. The second one is bellow gauges. The third one is diaphragm gauges. The fourth one is a dead weight gauges. These are various mechanical pressure gauging devices used for measuring the pressure. Now, according to your syllabus, there is no need to discuss all the types of pressuring devices. In this, you are having what is a manometer, what is a pressure gauge device, and in that you are having differential manometers. Here you are having micro manometer, piezometer, and also what are the various pressure devices. Next we'll discuss detailedly. Then, what is the meaning of a manometer device? A manometer is defined as a device used for measuring the pressure at a point in a fluid. అంటే ఒక fluid container లో ఫ్లూయిడ్ యొక్క ప్రెషర్ ని ఒక పాయింట్ దగ్గర ఏదో ఒక పాయింట్ దగ్గర కనుక్కోవడానికి we are using manometers by balancing the column of fluid by the same or other column of fluid. అంటే ఒక కాలమ్ ఆఫ్ ఫ్లూయిడ్ పక్కన ఇంకోటి దానికి స్టాండర్డ్ గా మెజర్ గా పెట్టి with the same fluid or different fluid, whenever you are comparing the height, comparing the ratios of pressure, that type of device is nothing but the manometer device, right? These are used for balancing the column of the fluid, use it for balancing of column of the fluid by the same or other number of other type of fluid. So these are simply nothing but the manometer. Next, what is the second one? Mechanical gauges. So these are the mechanical gauges are nothing but pressure gauges also. So these are the gauges which are defined as devices used for measuring the pressure, same pressure at a point in a fluid by balancing the fluid column by the spring or dead weight. So below you are having other device nothing but spring or a dead weight. అందుకే దట్స్ వై వీఆర్ కాలింగ్ దెమ్ యాజ్ మెకానికల్ ప్రెషర్ గేజెస్. అంటే మెకానికల్ లింకేజెస్ అనేవి ఈ గేజెస్ లో వాడతాము. ఫర్ ఎగ్జాంపుల్ if you are going if you want to fill the air in your scooter tire, if you want to fill the air in your tire of a scooter or a cycle, then what you will do, you will go for a person for filling up the air on the roadside. Then what a person will do, he is having a round type of device where it is connected to the pipe, where you are having a small stylus at the other end of this device. So you are having a reading here. So 1 2 3 4 you are having the pressure reading 10 15 20 25 like that you are having a reading in this device. So whenever what he will do, whenever you want to check plus or minus air pressure, he will take this device and he will place in that gap and we will press it. Then he can see how much pressure is there in the air, in the tire, in the tube. Then he will fill the air or he will reduce the air. That type of devices are known as mechanical pressure gauge devices, right? Now we'll see each of them in detail. Now see the manometer concept. A manometer or liquid gauge. So generally manometer అనేది liquids తో measure చేస్తాము. అదే మెకానికల్ గేజెస్ వచ్చేసి స్ప్రింగ్ డివైజెస్ ఆర్ డెడ్ వెయిట్ డివైజెస్ తో చెక్ చేస్తాము. ఓకేనా? A manometer is a pressure measurement device which is used in relationship between the pressure and head to the relative readings. Give me the readings. So these are acting as a relationship between the pressure and head giving readings. Now a manometer device used to measure the pressure. A manometer ante enti, it is a device. A manometer is a device used to measure a pressure at a single or multiple points. So here it can be used for measuring the pressure at a single or multiple places lo measure cheyadaniki use avutundi in the single or multiple pipelines. So by seeing the construction you can come to know. So single pipeline lo single place lo gaani multi places lo gaani, multiple pipelines lo single places lo gaani multiple places lo gaani, used for measuring the pressure by balancing the fluid column by the same or another fluid column. So by doing the problems, you can see how the manometer reading works. Okay, na? Or if you once the college is opened, also if you come to the fluid mechanics lab, there also you can see how the manometer reading takes place, how the pressure gauge measurements readings takes place. Okay, na? Don't worry about that. Okay, so these are the devices used for measuring the pressure only at a single points or multiple points, or in a single or multiple pipelines by balancing what? Another fluid column placing near the original container what to measure. Okay, na? Next, in that manometer we will see the first thing is a piezometer. See the in the table, you are seeing the first thing is a piezometer. Now, what is a piezometer device? It is simplest form of fan manometer which is designed at the earlier stages. The manometer and kanukkune time lo. So the first and the simplest method is piezometer manometer. Piezometer type of manometer. So here what it is doing, the one end of this manometer is connected to the point. The one end of the manometer is connected to the point where the pressure is to be measured and other end is open to the atmosphere. Simple ga one end of this manometer device em chestamo, it is connected to the point ekkadaithe container lo water postamo, పోసిన తర్వాత ఏదో ఒక చోట డమ్మీగా if you take a point for measurement, at that point దగ్గర మనం మానోమీటర్ డివైస్ ఒక కనెక్టింగ్ ఎంట్రీ ప్లేస్ అక్కడ పెట్టి అదర్ ప్లేస్ ఇట్ షుడ్ బి ఓపెన్ టు ద అట్మాస్ఫియర్, అంటే ఓపెన్ టు ద ఎయిర్, అంటే గాలికి యు ఆర్ ఓపెనింగ్. దట్ టైప్ ఆఫ్ థింగ్ ఈస్ నథింగ్ బట్ ఏ పీజోమీటర్. అర్థమైందా? ఇట్స్ ద సింప్లెస్ట్ టైప్ ఆఫ్ మానోమీటర్ విచ్ ఈస్ వెరీ సింపుల్ ఇన్ కన్స్ట్రక్షన్. దాని యూజ్ ఏంటి? one end, ఒక end is connected to the pressure point in the container, other end is connected to the open to the atmosphere. Now see the figure. Okay na? So this is a figure of piezometer and piezometer is connected to the pipeline. Okay na? Now see what's happening here. So this is a container. Okay na? This one is a container. In that container you are pouring some water. So the lopala mottam water posam anukundam. So in this you are having the వాటర్. సో ఈ వాటర్లో ఏదో ఒక చోట సెంటర్లో కానీ ఇక్కడ కానీ ఏ ఈజ్ అ ప్రెషర్ పాయింట్ టు కన్సిడర్. అట్ పాయింట్ ఏ యూ హ్యావ్ టు సీ ద ప్రెషర్ ఆఫ్ ద లిక్విడ్. సో ద లిక్విడ్ ఈస్ ఇన్ ద వెజల్. ఇది ఒక వెజల్. యూ కెన్ టేక్ ఎనీ వెజల్. నౌ ద అట్మాస్ఫియరిక్ ప్రెషర్ ఈస్ ఎంటరింగ్ ఇన్ టు ద వెజల్ ఫ్రమ్ ద ఎయిర్. ఇది అవుటే కదా, జనరల్గా అవుట్ సైడ్ ఉంది. సో అవుట్ సైడ్ ద పీ అట్మాస్ఫియర్ ఈస్ ఎంటరింగ్ ఇన్ టు ద ఎయిర్. Now so if you are placing a piezometric glass tube, so simple glass tube anamata. Glass tube lo meer em chestunaru, piezometric glass tube you are placing by the side of the column of this container and checking for the pressure point. Then the difference in this levels, the difference in this one and this one levels of this gives a reading for the manometric reading అని చెప్పొచ్చు. ఓకేనా? Now see the derivation here. Consider a cylindrical vessel, any vessel. Consider a cylindrical vessel having a fluid filled in it and is open to atmosphere. అంటే జస్ట్ ఒక కొండ తీసుకోండి, కొండలో వాటర్ పోయండి, లేదంటే గ్లాస్ తీసుకోండి, గ్లాస్ లోపల వాటర్ నింపేసి ఓపెన్ టు ద అట్మాస్ఫియర్ పెట్టండి. నౌ కనెక్ట్ a piezometer glass tube as shown in the figure at the point where it is to be measured, such that the other end of the piezometer tube is open to the atmosphere. Okay na? So other end enti? So idi manaki piezometric anukunnam, piezometric device anukunnam. This piezometric glass device lo place near to the cylindrical vessel. Now the other end ekkadaithe manam pressure check cheyalo akkada place chesi the other end is open to the atmosphere, right? As soon as the piezometer glass tube is connected to the cylindrical tank, eppudaithe, now see the next point, whenever the piezometer glass tube is connected to the cylindrical tank, some amount of fluid rushes into the tube. Okay now, whenever this is connected to the fluid, some amount of fluid is connected to the tube. Some amount of fluid is connected to the rushes into the tube due to the atmospheric pressure outside the cylindrical tank. So ఈ outside బయట cylindrical tank లో atmospheric pressure normal బయట ఉంటుంది కదా temperature. Because of this temperature sucking action, whenever the one end of the tube is connected to the point where you are measuring, దానిలో నుంచి వాటర్ దీనిలోకి వస్తుంది. How? With this atmospheric pressure reaction outside the cylindrical tank. But as the other end of the piezometer glass tube is exposed to the atmosphere, ఏం జరుగుతుంది? అదర్ ఎండ్ as per the definition, it is connected to the open air. అంటే మనకి నార్మల్ గా బయటికి ఓపెన్ చేసేట్టు చూపించాలి. Exposed to atmosphere, then the atmospheric pressure acts at that open end also, and hence the fluid rises up to some level in the glass tube and does not overflow from the tube. And does not overflow from the tube. Simple గా ఏం చేశాడు ఇక్కడ, if you are taking a glass pot or if you are taking a circular tube, circular vessel where you are to check the pressure at a point PA towards the gravity. Okay, so the piezometric glass tube, piezometer అంటే ఏం లేదు, జస్ట్ ఒక గ్లాస్ ట్యూబ్ అంటే it is a L shape or it may be a so it is a L shape or it may be the U shape, or maybe the U shape where the fluid is entering into the tube. సో ఎప్పుడైతే మీరు piezometric device ని వెజల్ దగ్గర ఇన్సర్ట్ చేశారో, so whenever the fluid is going into the fluid, whenever it is the fluid is passing into the piezometer, so the fluid due to the pressure atmosphere outside, it is going and filling at some point, మనకి ఫుల్ గా ఫిల్ అవ్వదు, ఓకేనా, it is placing up to some extent up to here the liquid is there. Okay, now see here also the same point it is saying here. So it is the atmospheric pressure acts open to here and hence the fluid rises up to some level in the glass tube and does not overflow from the tube. So దీనిలోంచి మళ్ళీ spill అవ్వకూడదు, should not go outside of this one. ఇలా జరిగినప్పుడు piezometric reading అనేది జరుగుతుంది. How we will see means you have to see the total height of the piezometer glass tube and up to what level it is coming, that is one height. You have to see this height minus height, and with this pressure difference you have to calculate the formula. Now see the derivation here. You see the derivation, if pressure considered in the cylinder vessel is, cylinder vessel lo manaku pressure emundi, atmospheric pressure undi, cylinder pressure undi, okay na, P atmospheric is there plus PA is there. See the figure also here. సో దీనిలో ఏముంది, మనకి అట్మాస్ఫియరిక్ ప్రెషర్ PA ఉంది, ఆల్రెడీ ఇన్బిల్ట్ లోపల అట్మాస్ఫియరిక్ ప్రెషర్ ఆఫ్ వాటర్ ఉంది, తర్వాత అట్మాస్ఫియరిక్ ప్రెషర్ ఉంది. నౌ వాట్ ఇస్ కన్సిడరింగ్ హియర్, if the pressure considers in the cylindrical vessel P atmospheric plus PA and the piezometer tube లో ఏముంటుంది, P atmosphere ఉంటుంది, piezometric pressure gamma H ఉంటుంది, right? Now then you can take any letter there, you can take alpha H or beta H or whatever you can take, mu H or, so piezometer tube లో ఏముంది, P atmosphere plus gamma H ఉంది, గ్లాస్ ట్యూబ్ లో ఏముంది, P atmosphere plus PA ఉంది, then they will be equal, రెండు ఈక్వల్ గా ఉంటుంది, due to which the overflow of the fluid does not takes place. సో రెండు ఈక్వల్ గా ఉంటాయి కాబట్టి overflow of the liquid అనేది జరగదు, that is a condition this happening. Therefore we are calling them as P atmosphere plus PA is equals to P atmosphere plus gamma H. So this is a balancing equation. Now దాన్ని ఏం చెప్పొచ్చు మనము, atmospheric pressure దీన్ని మనం క్యాన్సిల్ చేసేస్తే what you are getting, PA is equals to gamma H. So take this as some point. Now where PA is a pressure at a point, PA is the pressure at a point A, and where pressure is required to measure in an open container, and gamma H is a specific weight. Gamma H is a specific weight of the fluid raised in the piezometric column. So ekkadaithe neeku water anedi fluid is passing into the piezometer and going to certain level, that is nothing but your gamma H. Okay na? Next, if the container is not an open one, so ఇంకొక కండిషన్ ఏంటి, when the container is closed, ఒక వాటర్ బాటిల్ అనుకుందాం, పైన క్యాప్ పెట్టేసాం అనుకోండి, ఫర్ ఇన్స్టెన్స్ లైక్ ఎ పైప్ లైన్, అంటే పైప్ లైన్ ఎగ్జాంపుల్ తీసుకున్నాడు ఇక్కడ, మనం వాటర్ బాటిల్ ఎగ్జాంపుల్ తీసుకున్నాం విత్ క్యాప్. నౌ అండ్ ఇఫ్ ద piezometer is connected to the bottle as shown in the figure 2.7a, ఇదేంటిది, ఓపెన్ టు ద అట్మాస్ఫియర్ కదా, P atmosphere ఓపెన్, ఇది వచ్చేసి క్లోజ్డ్ కంటైనర్, ఓకే, column. What happens here, see in the figure, to find the pressure inside the pipeline, the hydrostatic equation varies. Here the hydrostatic equation varies. That is equal to PA. Same iday formula. PA at the pressure at the point A is equals to P atmosphere plus gamma H. అంటే ఇక్కడ దీనిలో ఈ ప్రెషర్ ఉండదు కాబట్టి ఈ రెండు క్యాన్సిల్ చేయలేం కాబట్టి సో ఇది లేదు, ఇది జీరో ఇక్కడ. దిస్ ఈస్ జీరో. ఎప్పుడు whenever it is in closed condition, whenever it is in the closed condition, therefore pressure at a point A is equals to atmospheric pressure plus change in the height. Now if you are taking this one as a condition 2, then and if needed in terms of pressure head, so pressure head మనం ముందు చెప్పుకున్న ఫార్ములాస్ pressure head dividing the equation 2.8 A with the specific weight of water alpha gamma water, then what is the derivation here? HA, okay, height of a liquid at A is equals to H atmosphere height, pressure head at the atmospheric pressure head plus specific weight is equals to 10.3 plus specific 10.3 plus SH. So that is a thing, that is a equalization you are getting now. Hence the equation 2.8 this 2.8A 2.8B are the equations of hydrostatic pressure and hydrostatic pressure head. So generally derivations exams ki ravu, only the thing is small definitions and problems. In the first unit you will get define specific what are the properties of fluid, or define specific weight, or what is a capillary, what is a bulk modulus, ఈ formulas వస్తుంది, and small problems plus a big problem. Okay na? Next, so these are the equations which are related to the hydrostatic pressure and hydrostatic pressure head. Now what are the merits of the piezometer? The merits is very simple construction and very old method used for measuring the pressure head of a fluid. Second one, very economical, chala economical ga, cost wise lo, usage wise lo chala economical ga we can use this process. Then what is the demerits here? Not suitable for high pressure intensity. So whenever the fluids in the container which are of high pressure, at that point of time this piezometer device is not applicable. That is the meaning. Next, the pressure at gases cannot be measured. So other medium, ఏంటి other medium? Gases ని మనం కన్సిడర్ చేసినప్పుడు the pressures of gases cannot be measured. That is the meaning is giving. So these are the two main disadvantages for not using the piezometer manometer. Understood? Okay, we are going to the next type, YouTube, not YOU, not your YouTube. U inverted, that is a shape is U. ఇదొక టైప్ ఆఫ్ మానోమీటర్, ఇన్వర్టెడ్ టైప్ ఆఫ్ మానోమీటర్ రెండు ఉన్నాయి అన్నమాట. బట్ మనము ఈ టైప్ ఆఫ్ మానోమీటర్ గురించి డిస్కస్ చేసుకుందాం. Now in this YouTube manometer, what is the next thing? To overcome the problems, ఏదైతేదో ఈ రెండు ఉన్నాయి చూసారా, దిస్ ఆర్ ద టూ ప్రాబ్లమ్స్. ఏది పీజోమీటర్ కి మనకి ఈ రెండు ప్రాబ్లమ్స్ కదా, దీన్ని రెక్టిఫై చేయడానికి we are using YouTube manometer. Okay na? To overcome the problems with the piezometer, the YouTube manometer seals the fluid by using the measuring liquid. To overcome the problems with the piezometer, the YouTube manometer seals the fluid, closes the fluid. It will closes the fluid by using a measuring liquid. Okay na? That is a point we'll discuss here. Now, what is a in this YouTube manometer, simple type of manometric device used to measure a pressure at a point of a fluid by balancing the fluid column by the same or another column of fluid. Same formula, same definition you can place here also. What is this one? A YouTube manometer is a simple manometer device used to measure the pressure at a point in the fluid by balancing the fluid column by the same or other column of fluid. It has a glass tube bent in U shape. So ఏం చెప్తున్నాడు? It is having a major tube, that is a glass shaped U shaped tube which with some amount of same or other type of fluid called manometric fluid. ఏదైతే మనం fluid measure చేయాలో అదే fluid నైనా వాడుకొని we are calling them as manometric fluid, or other type of fluid ని తీసుకొని, it may be any oil or any water or any some sort of agent we can use for the same process. That is nothing but a U-tube manometer. So what is the definition here? Simple ga oka glass tube which is shaped, which is bent into U shaped for measuring the pressure at a given point in a liquid, where the type of fluid is also same or different, is nothing but a U-tube manometric fluid. Okay na? Or U-tube manometer device. Now if you see the figure, so this one is a exact figure of this U-tube manometer. It along the figure idi. So see here, it is U-shaped. So itla on the U-shape lo construct chesi undi. Okay na? Mundu shape lo ela undi, just a piezometer is L shape. That's all. Now if you see the derivation here, consider a pipe carrying a fluid. Consider a pipe carrying a fluid called fluid 1. So see here the fluid 1. So ఇది ఒక కంటైనర్ అనుకుందాం, ఒక chamber, closed chamber, where you are having a pressure point at A and it is atmosphere, open to the atmosphere. Now a fluid 1 is in the closed pipe. The fluid 1 is in the closed pipe. Now what is saying, with a specific weight gamma y1 with gamma 1, and let pressure PA to be measured at a point A. So దీనిలో మనం ఏం కనుక్కోమన్నాడు? So pressure A, let pressure PA to be measured at a point A in the pipe. So ఇక్కడ point A. So see the point A. At this point you have to find the pressure. Now let the manometric fluid have specific weight y gamma 2. As the U-tube manometer is connected to the pipe, the fluid 1 rushes into the U-tube and pushes the manometric fluid upwards in the other limb of the U-tube. So whenever you have to check this, whenever you have to check the value, whenever you have to check the pressure, whenever you have to check the pressure, the F1 fluid rises. So the F1 fluid ఏదైతే మనం పేరు పెట్టుకున్నామో, it is going into the piezometer, it is going into the U-tubed, U-shaped piezometer, and it is passing into the chambers, and it is mixing with this manometric fluid and raising. So whenever it is raising like this, beyond the regular manometric fluid, then the difference, whatever you are seeing, then the difference, see, U-tube pushes the manometric fluid upwards in the other limb of the U-tube, due to which the initial manometric fluid level is shown in the figure 2.8a. Now see, so whenever this water is coming onto the tube and pushing this manometric fluid, then what happens? ఈ లోపల ఉన్న fluid ఏం జరిగింది? This fluid is going upward. This fluid is going upward in the tube. Now ఇక్కడ ఏం జరిగింది? You are getting a pressure difference, right? You are getting the change in the height also. You are getting a change in the height also. Now pressure 2A is distributed on the layers of the left limb and raised up with the pressure of head H2 in the right limb of the U-tube. In the right limb of the U-tube. See here. So in the right limb, pressure H2 అనేది పైకి లేస్తుంది. That's the meaning of this sentence. Okay. Right. Next, let the fluid F1 in the pipe occupy the U-tube column. Let the fluid F1 in the pipe occupy the U-tube column in the left limb of height H1, and let the manometric fluid in the U-tube be raised up in the H2 in the right limb. So nothing. Aim with the figure use you can write. So whenever the fluid in the container is filling the left leg of the U-tube with H1 height, and the manometric fluid which is in the glass tube is rising up to the height H2 in the right level leg అని మనం కూడా సొంతంగా we can say by seeing the figure. ఏం చెప్తున్నాడు? Due to the push given by the fluid 1 into the manometric fluid. So what happens here? Due to the push of F1, due to the F1 fluid push, ఎప్పుడైతే దీని నుంచి దీనిలోకి జరిగిందో what happens the changes there. So here the manometric fluid may be overflow, but it does not happen due to the reason that the atmospheric pressure acts in the open on the open end of the U2B shown in the 2.8b. So what it is saying, whenever this water is pushing this water, so it will cross the limit, but it will not escape outside, spill outside. Why? Because of the pressures acting inside the tube. Why? Because it's open to atmosphere, it will balance the, it will not balance, it will give some changes in the pressure head, but the water will not go outside, the water will not leave outside. These are the main things. Okay, but does not happen due to the reason that atmospheric pressure acts on the open end of the U-tube, as shown in the 2.8 figure B. Okay, na? Due to the push given by the end fluid 1 onto the manometric fluid, the manometric fluid may overflow, but it does not happen due to the reason that the atmospheric pressure acts as the open of the U-tube. So it is saying it does not overflow because of the pressure differences between the tubes. So thereby it is happening in this process. So you don't have any issues of this problem. Okay, na? See, just before connecting the YouTube, after connecting the YouTube. So YouTube connect చేయక ముందు దిగిన ఫోటో, the YouTube manometer YouTube కి కనెక్ట్ చేసిన తర్వాత దాని యొక్క చేంజెస్. See, if this is a datum line, xx is the datum line, x1 is the datum line. So whenever the height of the liquid from the pipe is h1, so whenever the manometric fluid is passing to a height h2, then there is differences is showing in the figure. Understood? Next, now using this same thing under the equilibrium of pressures, of left hand side of the U-tube must be equal to the right hand side of the U-tube. The same formula what you have done in this piezometer also. Here also you can do the same process. PA, pressure at a point A, plus gamma 1 H1 is equals to atmospheric pressure in the U-tube plus gamma 2 H2. There is a 0.1. Now what you are doing, just you are commoning PA plus gamma W, specific weight, gamma W, gamma 1 H1 is equals to S1 H1 is equals to gamma W H2 S2 plus P atmospheric pressure. Now after getting the processing, that implies PA by gamma W is equals to HS2 minus HS1, HS2 minus HS1. Thereby the gamma W getting closed, you are getting this process. Next, PA by gamma W is equals to the changes. PA by gamma W is equals to the PA by gamma W is equals to H2S2 minus H1S1, which is meters of water. Therefore H is equals to S2H2 minus H1S1. Therefore the pressure head height is equals to S2H2 minus H1S1. So if you are considering the hydrostatic pressure, then H is equals to S2H2 minus H1S1 plus 10.3. Whenever you are using the hydrostatic pressure annappudu 10.3 ki actual formula lo add cheyali, right? So this is happening in the U-tube manometer. So whenever you are using normal U-tube manometer without the hydrostatic pressure, the formula is equals to H is equals to S2H2 minus H1S1. Whenever the hydro pressure is used, H is equals to S2H2 minus S1H1 plus 10.3 should be added, where H is equal to pressure head at a point A, where pressure is wide, right? Now if you see the problem related to the YouTube manometer. Now see here, the pipeline carrying the water has a connection of a mercury. A pipeline. So if the pipeline lopala emundi, what is the fluid you are having? You are having a mercury as a medium. Here the pipeline carrying the water. The pipeline la ఉంటుంది closed ga ఉంటుంది. So this is a pipeline. This is a pipeline carrying water to some level. Okay. Pipeline carrying water has a connection of a mercury manometer connected to it. So the లోపల ఏముంది, manometer లోపల mercury fluid అనేది ఉంది. సో ఇప్పుడు ఏం చేస్తున్నాం, ఇక్కడ మనము ప్రెషర్ అట్ పాయింట్ పైప్ లైన్ కనుక్కుంటున్నాము. ఓకే, ద పైప్ లైన్ క్యారీయింగ్ యాజ్ ఎ కనెక్షన్ ఆఫ్ ఎ మెర్క్యూరీ మానోమీటర్ కనెక్టెడ్ టు ద థింగ్. నౌ ద రీడింగ్స్ ఆర్ మెజర్డ్ యాజ్ షోన్ ఇన్ ద ఫిగర్. ఫైండ్ ద ప్రెషర్ ఆఫ్ ద వాటర్ ఫ్లోయింగ్ ఇన్ ద పైప్ లైన్. So this is a general figure given for the YouTube type of manometer. Now the given data is as per given. General simple example here, already given data. The question ఇవ్వలేదు, but question ఏమి ఇచ్చాడు, with this figure, with this h1 is the height, h2 is the height, you have to find PA, h1 is equals to 0.1 meter అని ఇచ్చాడు. It is already given. h1 is equals to h1. See the question here, h1 is equals to 0.1 meter, h2 is equals to 0.8 meter. Specific weight of water and specific weight of mercury is 1. Specific weight of water is equals to 1. Specific weight of mercury is equals to 13.6. Now equating by taking the formula, h of S1 S water is equals to h2 S mercury. Okay, mercury, we have h plus h normal total height, h plus 0.8 into 13 point. Just substituting the values, h is equals to minus petkondi that helping kabatti h is equals to 0.8 into 13.6 minus 0.1 into mercury vachesi 1 untundi. So totally what you are discussing, 10.78 meter is the height. Next, so pressure kanukkundam. Pressure in the pipeline, PA, pressure in the pipeline PA is equals to rho into water into GH. Pressure in the pipeline is equals to rho GH is the old formula. Now rho of water is equal to 1000 to G is equal to 9.81 into whatever the H is given is 105.7 kilopascals. Now, so if ever the hydrostatic pressure is applied, ఏది ముందు ఫార్ములా, if ever the hydrostatic pressure is applied, then what we will do, PA pressure కాబట్టి PA is equals to rho of G into H plus 10.3. ఇక్కడ ఇలా ఇచ్చాడు, ఇక్కడ వచ్చేసి when now rho is coming into the picture, we have pressure at a point A is equals to rho of water into G into height ఎలా వస్తుంది, H plus 10.3, H plus 10.3. okay na. Now what is the answer here, H అనేది మనకు తెలుసు ఎంత, 10.78 plus 10.3, they are getting totally 206.75 kilopascal. There is a hydrostatic pressure to be obtained. Understood here? Okay, so like this we will solve the problem by taking the simple manometric readings. Okay na. The second one, you are having a single column micrometer. See the figure here, only the change in the, only this chamber is missing in the YouTube concept, right? So this is nothing but a micro type of single column manometer. So here also you are having single column manometer. You are having a closed pipeline where you are having a point A to be measured. Okay, next, here also the atmospheric pressure which is open to the air. YouTube single column micrometer lo em jarigindi, the other end of the pipeline is connected to the atmosphere, the one end of the pipeline is connected to the closed pipeline, right? So when now the water is entering into it, when now the atmospheric pressure is entering into it, whatever the changes happening, it can be shown in this glass type of system. That is nothing but the manometers. right? Here we are using liquid as a medium, whereas in the pressure gauges we are using as a, which one we are using as agent? We are using a spring. We are using as a spring or a bearing for changes, for getting changes in the concept. So that is about the YouTube manometer. Next we'll discuss the single column type of micrometer in the next classes. So if you have any doubts in the before session, before slides, you can share with me. So any doubts up to here? If you have any doubts, just share with me. Also the time is also ending up. Any doubts, you can share with me. Raviteja, RAJESH.K, Snehalata. Starting with the ముగ్గురు వచ్చారు, వాళ్ళు వెళ్ళిపోయారు. Only you are having 4 persons in this class. So I'm taking a screenshot of your today's screenshot. Okay. Any doubts still here? Just let me know. Any doubts still here about the pressure at a point, measuring of pressures? Any doubts? Problems theory? No doubts? Shall I close the class? No response from your side. Okay. Okay. Right. Thanks. We'll end up the class here. In the next class, 2:15, we'll continue the class. Thank you.
అడే ఇలాంటిది ఒక ప్యాంట్ ఉంది. అదే ఫోన్ ఉంటుంది.